Now that we've looked at the four main types of intermolecular forces, we can now answer the question, what is the strongest intermolecular force in a molecule? So of the four intermolecular forces we've talked about, ionic is by far the strongest. Hydrogen bonding is next. It's quite a bit weaker. Then a dipole interaction, and then dispersion interaction. So when we're trying to compare molecules in terms of their melting points and boiling points, what we're interested in is the strongest intermolecular force. That's going to be the force that determines boiling point and melting point. So to find the strongest intermolecular force, what we're going to do is we're going to ask questions. We're going to say, does the molecule have an ionic intermolecular force? If the answer is no, we say, is it H bonding? If no, does it have a dipole? If no, then dispersion. So we want to know what's the strongest intermolecular force. So dispersion forces are actually always present, so that's the idea. Even in the worst case scenario, we have a nonpolar molecule, we always have a dispersion force present. But that's not interesting to us if a molecule has a dipole or a hydrogen bonding intermolecular force. So the questions are, I start at the strongest. I say, given a molecule, I want to know what its intermolecular force is. I say, is the molecule ionic? By that I mean, do we see a metal bonded to a non-metal in there? If the answer is yes, I can stop. I don't care if it has any of these three other intermolecular forces, because ionic is the strongest. If the answer is no, I continue on, and then I say, is the molecule hydrogen bonding? And with that, I look at the molecule and I say, do I have an HF, HN, or HO bond inside of there? If the answer is yes, it's hydrogen bonding. I don't need to continue on. But if the answer is no, then I say, is the molecule polar or not? So that's a little bit trickier. We talked about that, how do you look at a molecule and tell if it's polar? If the answer is yes, then the molecule has a dipole intermolecular force. And then if the answer is no, you always have a dispersion intermolecular force. So if I don't have one of these three stronger intermolecular forces, then I always have a dispersion intermolecular force. So I ask these three questions. If the answer is no on all three, what we have left over is a dispersion intermolecular force. So even though a molecule may have weaker intermolecular forces, we are only concerned with the strongest. So pretty much every molecule has some type of dispersion intermolecular force. We don't care about that. We want the one that's the strongest. So let's do an example. I give you four molecules here, and I say, what's the strongest intermolecular force for each molecule? And then I say, which one do I expect to have the highest melting point, and which one do I expect to have the lowest melting point? So this is like asking which one has the strongest intermolecular force, which one has the weakest intermolecular force. So for this first molecule, I start at the top. Is ionic? Is there a metal bonded to a non-metal? No. Is it hydrogen bonding? Does it have HF, HO, or HN? No. Is the molecule polar? So when I look at that, I see that this is actually a tetrahedral molecule where the substituents are not all the same. That means that this molecule is going to be polar. And you can kind of see that once you get used to it, there is going to be a polarity on there. That we have these PCl bonds pulling in one direction, we have a lone pair electron pulling in the other direction. There's not going to be a perfect non-separation of charge. So this first molecule is going to be polar, which means it has a dipole intermolecular force. For this next molecule, same thing. I start at the top. Is that ionic? Is there a metal bonded to a non-metal? No. Is there hydrogen bonding? No. I don't see an OH, NH, or FH bond inside of there. Then you say, is the molecule polar? When I look at this, okay, now it is a tetrahedral molecule, 4 groups of electrons around our central atom. Every substituent attached to that central atom is the same. So it is non-polar. So it does not have a dipole intermolecular force. So what's left over, if I don't have any of those three stronger ones, this has a dispersion intermolecular force. So for the next molecule, start at the top. Is ionic? Metal bonded to a non-metal? No. Is it hydrogen bonding? And so here I see that there is an oxygen directly bonded to a hydrogen. So this is going to have a hydrogen bonding intermolecular force. So for the last one here, I start off at the top. Is it a metal bonded to a non-metal? Yes. Sodium is a metal. It's on the left-hand side of the periodic table. Chlorine is a nonmetal. It's on the right-hand side of the periodic table. So this last one has an ionic intermolecular force. So of this group, sodium chloride here, number 4, has an ionic intermolecular force. That's the strongest intermolecular force. We would expect it to have the highest melting point. And then number 2 here, which is methane, it only has a dispersion intermolecular force. It's the weakest intermolecular force. We would expect it to have the lowest melting point.